Chapter 7 Wrap Up. This chapter began our introduction to data structures, exploring the use of arrays and vectors to store data in and retrieve data from lists and tables of values. The chapter examples demonstrated how to declare an array, initialize an array, and refer to individual elements of an array. We also illustrated how to pass arrays to functions and how to use the const qualifier to enforce the principle of least privilege. Chapter examples also presented basic searching and sorting techniques. You learned how to declare and manipulate multidimensional arrays. Finally, we demonstrated the capabilities of C++ standard library class template vector, which provides a more robust alternative to arrays. In that example, we also discussed basic exception handling concepts. We continue our coverage of data structures in Chapter 14, Templates, where we build a stack class template, and in Chapter 20, Custom Templatized Data Structures, which introduces other dynamic data structures, such as lists, queues, stacks, and trees, that can grow and shrink as programs execute. Chapter 22 introduces several of the C++ standard libraries' predefined data structures, which you can use instead of building their own. Chapter 22 presents the full functionality of class template vector and discusses many additional data structure classes, including list and deque, which are array-like data structures that can grow and shrink in response to a program's changing storage requirements. We've now introduced the basic concepts of classes, objects, control statements, functions, and arrays. In Chapter 8, we present one of C++'s most powerful features, the pointer. Pointers keep track of where data and functions are stored in memory, which allows us to manipulate those items in interesting ways. After introducing basic pointer concepts, we examine in detail the close relationship among arrays, pointers, and strings. Summary. Section 7.1 Introduction. Data structures, page 268, are collections of related data items. Arrays, page 268, are data structures consisting of related data items of the same type. Arrays are static entities in that they remain the same size throughout program execution. They may, of course, be of automatic storage class and hence be created and destroyed each time the blocks in which they are defined are entered and exited. Section 7.2 Arrays. An array is a consecutive group of memory locations that share the same type. To refer to a particular location or element in an array, we specify the name of the array, page 269, and the position number of the particular element in the array. A program refers to any one of an array's elements by giving the name of the array followed by the index, page 269, of the particular element in square brackets. The first element in every array has index 0, page 269, and is sometimes called the zeroth element. An index must be an integer or integer expression, using any integral type. The brackets used to enclose the index are an operator with the same precedence as parentheses. Section 7.3 Declaring arrays. Arrays occupy space in memory. You specify the type of each element and the number of elements required by an array as follows. Type array name, array size. And the compiler reserves the appropriate amount of memory. Arrays can be declared to contain any data type. For example, an array of type char can be used to store a character string. Section 7.4 Examples using arrays. The elements of an array can be initialized in the array declaration by following the array name with an equals sign and an initializer list, page 272, a comma-separated list, enclosed in braces, of constant initializers, page 272. When initializing an array with an initializer list, if there are fewer initializers than elements in the array, the remaining elements are initialized to 0. If the array size is omitted from a declaration with initializer list, the compiler determines the number of elements in the array by counting the number of elements in the initializer list. If the array size and an initializer list are specified in an array declaration, the number of initializers must be less than or equal to the array size. Constants must be initialized with a constant expression when they're declared and cannot be modified thereafter. Constants can be placed anywhere a constant expression is expected. C++ has no array bounds checking, page 280. You should ensure that all array references remain within the bounds of the array. A static local variable in a function definition exists for the duration of the program but is visible only in the function body. A program initializes static local arrays when their declarations are first encountered. If static array is not initialized explicitly by you, each element of that array is initialized to 0 by the compiler when the array is created. Section 7.5 Passing arrays to functions. To pass an array argument to function, specify the name of the array without any brackets. To pass an element of an array to a function, use the subscript name of the array element as an argument in the function call. Arrays are passed to functions by reference. The called functions can modify the element values in the caller's original arrays. The value of the name of the array is the address in the computer's memory of the first element of the array. Because the starting address of the array is passed, the called function knows precisely where the array is stored in memory. Individual array elements are passed by value exactly as simple variables are. To receive an array argument, a function's parameter list must specify that the function expects to receive an array. The size of the array is not required between the array brackets. The type qualifier const, page 273, can be used to prevent modification of array values in the caller by code in a called function. When an array parameter is preceded by the const qualifier, the elements of the array become constant in the function body, and any attempt to modify an element of the array in the function body results in a compilation error. Section 7.6 Case Study, Class Gradebook using an array to store grades. Class variables, static data members, page 290, are shared by all objects of the class in which the variables are declared. A static data member can be accessed within the class definition and the member function definitions like any other data member. A public static data member can also be accessed outside of the class, even when no objects of the class exist, using the class name followed by the scope resolution operator, smiley face, and the name of the data member. Section 7.7 Searching arrays with linear search. The linear search, page 293, compares each array element with a search key, page 293. Because the array is not in any particular order, it's just as likely that the value will be found in the first element as the last. On average, a program must compare the search key with half the array elements. To determine that a value is not in the array, the program must compare the search key to every element in the array. Section 7.8 Sorting arrays with insertion sort. An array can be sorted using insertion sort, page 295. The first iteration of this algorithm takes the second element and, if it's less than the first element, swaps it with the first element, i.e., the program inserts the second element in front of the first element. The second iteration looks at the third element and inserts it into the correct position with respect to the first two elements, so all three elements are in order. At the ith iteration of this algorithm, the first I elements in the original array will be sorted. For small arrays, the insertion sort is acceptable, but for larger arrays it's inefficient compared to other more sophisticated sorting algorithms. Section 7.9 Multidimensional arrays. Multidimensional arrays, page 297, with two dimensions are often used to represent tables of value e's, page 297, consisting of information arranged in rows and columns. Arrays that require two subscripts to identify a particular element are called two-dimensional. Arrays, page 297. An array with m rows and n columns is called an m by n array, page 297. Section 7.11 Introduction to C++ Standard Library Class Template Vector. C++ Standard Library Class Template Vector, page 307, represents a more robust alternative to AR. Arrays featuring many capabilities that are not provided for C-style pointer-based arrays. By default, all the elements of an integer vector object are set to 0. A vector can be defined to store any data type using a declaration of the form. Vector type name, size. Member function size, page 311, of class template vector returns the number of elements in the vector on which it's invoked. The value of an element of a vector can be accessed or modified using square brackets. Objects of standard class template vector can be compared directly with the equality, equal sign, and inequality, is not equal to sign operators. The assignment, equal sign operator can also be used with vector objects. An unmodifiable value is an expression that identifies an object's memory, such as an element in a vector, but cannot be used to modify that object. A modifiable value also identifies an object in memory, but can be used to modify the object. An exception, page 312, indicates a problem that occurs while a program executes. The name exception suggests that the problem occurs infrequently. If the rule is that a statement normally executes correctly, then the problem represents the exception to the rule. Exception handling, page 312, enables you to create fault-tolerant programs, page 312, that can resolve exceptions. To handle exceptions, place any code that might throw an exception, page 312, in a try statement. The try block, page 312, contains the code that might throw an exception, and the catch block. Page 312 contains the code that handles the exception if one occurs. When a try block terminates, any variables declared in the try block go out of scope. A catch block, page 312, declares a type and an exception parameter. Inside the catch block, you can use the parameter's identifier to interact with a caught exception object. An exception object's what method, page 313, returns the exception's error message.